Hi, my name is Andrew Waugh from Waugh Thistleton Architects. We are an architects practice based in London, and for the last 20 years or so have been working primarily in mass timber, in engineered timber. The reason why we work in timber as a practice is about understanding and reducing our impact on the environment, about building with low carbon technologies and thinking about our industry, about the construction industry, about architecture, engineering, and how we can transform the way in which we practice to reduce our impact on climate change. So the Solar Decathlon competition this year will be focused primarily on these kind of future conditions of construction and how we can primarily reuse the buildings that we have already, reuse existing buildings, thinking about closing the gaps perhaps between these buildings, thinking about extending existing buildings, refurbishing them, thinking about the insulation of those buildings, improving the fabric of those buildings, how we might be able to extend those buildings using prefabricated timber elements. So this is going to become, we believe, an increasingly important part of what an architect, a modern engineer, what the construction industry is involved in. Now, we built our first mass timber building in 2003. We've built, I don't know, nearly 30 of them since then in the UK and France, and now we have projects across Europe and in the United States. And for me, you know, one of the major benefits alongside the reduction in carbon about building in timber is also the process of prefabrication, the process of construction with timber elements, with these prefabricated timber elements. Because you are prefabricating so accurately in a factory, the connection between the architect and what is built is so immediate, and the process of construction so much clearer in terms of the information that's prepared and the product that's produced, that kind of link between what we draw as architects and engineers is really what is arriving on site. And that opportunity for quality, for speed, for getting things right, because we're reconnecting with construction, I think is really exciting. And also we have these building sites that are clean and healthy, that don't require masks and goggles, that are non-toxic, that send very, very little waste to landfill and are quiet. So these are really big advantages, not only for the people working on site, but for the people, you know, for the neighbours and for the people in the community adjacent to these construction sites. Also, building in timber, we know that timber buildings create an atmosphere of kind of natural harmony for people to live in. This biophilic response that we have to natural materials as human beings helps us to relax, reduces our heart rate and our blood pressure, helps us sleep better, helps us concentrate better. So we know that these are healthy buildings, not only to build, but healthy buildings to live in. And also because these buildings are made of a material that is easy to adapt. It's easy to, you know, cut a new window out, build a new staircase, take the building down, reuse those elements again. Because this is so much more straightforward with a tectonic building process from such a lightweight and malleable material, then we can see that these buildings will last well into the future, that the elements that we're constructing these buildings with, the timber elements we're constructing these buildings with, can be reused, repurposed, and if necessary, recycled. So these are buildings that will last well into our future because of their adaptability. So my belief is that architects in university at the moment, architects that are beginning their professional careers, need to really learn to understand timber, to understand the engineering of timber. These are buildings, don't forget, that weigh maybe a third of what a concrete and steel building might weigh. So we're always thinking about wind load. We're always thinking about the engineering of these buildings in order that we can use less timber, in order that we can be frugal with the amount of timber that we can use. So I think the future of these structures will ever more be about that connection between sophisticated computational systems, parametric modeling, and that beautiful, natural, elemental material in terms of timber. And how we engineer that timber, I think, will become also incredibly, increasingly more sophisticated. So what we're going to be looking at in the Solar Decathlon, as I was saying before, is what we can do with existing buildings, adding stories, refurbishing, closing those urban gaps, and then thinking about what the future of CLT, cross-laminated timber, LVL, thinking about the efficiency of the trees that we use, of the forests that they come from, thinking perhaps are there opportunities to combine other technologies, rammed earth, hempcrete, straw, cork, other kinds of bio-based low-carbon materials. Is there a place for steel? If those steel sections are standard sections and we can reuse them, are there opportunities to incorporate those within hybrid systems? So loads of questions, loads of opportunity, and I think this is a moment for architects, engineers, designers to really rise to the challenge of a new era, which will be dominated by our response to the climate emergency. Thank you.